Hi everyone! In this video, we're going to label all important angles around the unit circle with radian measures. We're going to start by labeling three special angles, 30, 45, and 60. And while we already learned how to perform conversion from degrees to radians using special ratios, to find the equivalent radian measures for these three angles, it's actually very easy if we use those two qualities. For example, to find the equivalent radian measure for a 30-degree angle, I can use the fact that 180 degrees equals pi and divide each side by 6. 180 divided by 6 gives me 30 degrees, and I can see that it's equivalent to pi over 6 radians. Similar way, I can find what 60-degree angle is equivalent to in radians. If 180 equals pi, then dividing both sides by 3 will help me to see that 60-degree angle is equivalent to pi over 3 radians. I skipped 45-degree angle, so let's work on it now. I'm going to use the fact that 90 degrees equals to pi over 2 radians. Well, I know that 45 is half of 90. So what I'll do, I'll multiply both sides of that equality by 1/2, times 1/2 on the left, times 1/2 on the right, and that tells me that 45-degree angle equals pi over 4 radians. Okay, so now we have those three special angles converted to radians. So let's add radian measures to other important angles on the unit circle. Of course, we can simply convert each one by one, but I'm going to show you a quick way for converting a lot of them at the same time. For that, you need to notice that if I start counting around the unit circle by 30 degrees, then this is what I'm going to obtain. So from here to here plus 30, I'll get to 30. Another plus 30, I get to 60. Plus 30, I am at 90. Plus 30, I am at 120. You got the idea, right? So as we keep adding 30, we always hit angles that are either related to 30-degree angle, 60-degree angle, and we're also going to hit quadrantal angles, the ones that terminate on either x or y axis. Well, if that happens when we count by 30 degrees, same thing should happen when we count by its equivalent in radians. And what is the equivalent of 30 degrees in radians? Well, we know it's same as pi over 6. So what we're going to do, we're going to count by pi over 6 around the unit circle. So plus pi over 6, then I'm going to add another pi over 6 and another pi over 6 and so on and so forth. And the beauty of this method is that adding fractions that have same denominators are always easier because we just keep the denominator and we only add the numerators. So that means that I'll get, well, I'm going to write pi over 6 again here. I already see that. Then pi over 6 plus pi over 6 give me 2 pi over 6. And of course, I can see how it's the same as pi over 3 if I simplify this fraction. Then as I add another pi over 6, I'm going to get 3 pi over 6. See how it's the same as pi over 2, which we know is the equivalent of 90-degree angle. But let's keep going. By the way, I'm not going to simplify fractions yet because I want to keep same denominators. I'll simplify them once I am finished with this process. So as I add another pi over 6, it's going to be 4 pi over 6, 5 pi over 6, 6 pi over 6, and all the way to 12 pi over 6. And now I can come back and simplify everything that can be simplified. Just to confirm that I counted correctly, I'm going to simplify the last value I got, 12 pi over 6. Well, that's same as 2 pi. And that's exactly what I had to get at 360, right? 360 is same as 2 pi. Okay, so that means that I counted correctly. Now let's see what else we have to simplify. I'm going to box like my final answers here. Pi over 6. That one we said, well, we kind of converted here. Pi over 3, pi over 2 is up here. 4 pi over 6, 4 pi over 6. If I divide out 2, I'm going to get 2 pi over 3. 5 pi over 6 I cannot simplify. I'm going to box that. 6 pi over 6. If I divide out 6, I'm going to get pi. And we know that 180 is same as pi. Okay, that's good. 7 pi over 6. 8 pi over 6. That I can simplify. I can divide out 2, right? So it's 4 pi over 3. 9 pi over 6. Here I can divide out 3. So it's 3 in the numerator, 2 in the denominator. 2 pi over 3. 10 pi over 6. If I divide out 2, I'm going to get 5 pi over 3. And 11 pi over 6. Now this was kind of our scratch work, and I'm going to show you a clean version of what we've got so far. Okay, so these are the radian values that we just added to the important angles around the unit circle. And before we move on and finish this by filling in just a few more angles that are left, I want to point out something important and useful. Let's locate all angles that are related to 30 degrees, or now we can say that are related to pi over 6. Same thing. Well, here they are. Angles related to pi over 6 are pi over 6 itself, 5 pi over 6, 7 pi over 6, 11 pi over 6. And of course I can continue. These are just the angles within one full revolution, or within 2 pi. But what do they all have in common? What can we notice here? Well, that's the fact that they all have same denominator. So angles related to pi over 6, if we put that value in the simplified exact form, its denominator will always be 6. And that's going to be very useful when we're working with radian measures and need to use reference angle. So let's check if we're going to find same pattern if we look at angles related to 60 degrees, or I should say pi over 3. So here they are. And again, we can see that all angles related to pi over 3 have same denominators, of course, when they're written in the simplified form, and that is denominator 3. Okay, and finally what we need to do is to fill in radian measures for angles related to 45-degree angle. And I'll use same trick. So I notice that when I count by 45 degrees, what happens is that I either hit quadrantal angles or angles related to 45. And that should happen same way if I count by equivalent radian measure, pi over 4. So plus pi over 4, and then again plus pi over 4. So what are we going to get? Of course, first we hit pi over 4 itself, then pi over 4 plus another pi over 4, that's 2 pi over 4. But of course that simplifies to pi over 2. I'm going to stop simplifying for now. So 2 pi over 4 plus another pi over 4. That's 3 pi over 4. And then I'm going to get 4 pi over 4, 5 pi over 4, 6, 7, and finally 8 pi over 4. So let's go all the way around and see if anything has to be simplified. Now 3 pi over 4, that cannot be simplified, I'll box that. Of course 4 pi over 4 is the same as pi, we already knew that it's here, but just a good way to double check our counting. 5 pi over 4, it's the simplest form. 6 pi over 4, it's same as 3 pi over 2, we already had that value labeled. And then 7 pi over 4 here, and 8 pi over 4 is same as 2 pi. Okay, so that's the clean version of what we just got. And basically, the only new angles that we added to the unit circle are the ones related to pi over 4. And once again, the pattern that we observed is being confirmed here as well. All radian measures of angles related to pi over 4 have the same denominator, and that's denominator 4. And with the radian measures labeled all the way around the unit circle, we're ready to learn how to find trigonometric function values of angles expressed in radians. And guess what? The steps will not be that much different when we work with degrees. So all that you'll see in the next videos.